If you would like to follow along with this video tutorial, you will find this starter packet tracer file under my danscourses.com CCNA3 area, and the topic heading is First Hop Redundancy Protocols, or HSRP, Hot Standby Routing Protocol. Now, one of the cool new things about the new Cisco CCNA 5.0 curriculum is the inclusion of first hop redundancy protocols, and in particular, Cisco's HSRP, Hot Standby Routing Protocol, is featured. And using Packet Tracer 6.1, you can actually execute a lab and configure Hot Standby Routing Protocol to make it work. So that's what I'm going to do here. I'm going to show you an example of how it would work using Packet Tracer, and you can download this starter file from my website. Okay, let's get started. So in this scenario, I've got my PC over here, and I'm 192.168.1.100, and the gateway right now is 192.168.1.2, which is router R1 right here. It's its gigabit 00 interface. You can see them labeled right here. So the PC can ping the gateway and then get out through the edge router and then out to the internet. You can see over here I've got ISP-A at 209.165.200.14. So let's verify first that PCA can communicate to the internet service provider out here in the cloud. So I'll open PCA here, go to the command prompt, and I'll ping the ISP. So you can see that I'm getting replies from the ISP, so I'm able to get out. Now if we take a look at this, we say, all right, PCA is going through R1. The R1 is the gateway at 1.2, and then through the edge router and to ISP-A. Now these routers here are router R1, R2, and the edge router are sharing routes using OSPF. And then the edge router has a default route going out to the ISP, and the ISP has essentially a default route coming back, and then OSPF shares that information to the other two OSPF routers. If you want to look at those configurations, all you have to do is open up the routers and look at the running configurations to see that. So let's talk now about Hot Standby Routing Protocol. Hot Standby Routing Protocol can be used in a situation like this where you have two routers on your network and you want to use one of the routers as a backup gateway. So for instance, since right now R1 is our gateway, what if R1 goes down? Couldn't we have R2 take over the gateway duties? Now, you could do that by just reconfiguring your PC with a new gateway address, and now R2 would be the new gateway. But you want this to happen seamlessly on your network so that your clients, the hosts on your network, never know that the router went down, and it's just seamless. There's no downtime. One router goes down, the other router takes over the duties. Now, Hot Standby Routing Protocol allows you to do this. So the basic way it works is this. Instead of R1 being the gateway at 192.168.1.2, so the basic way it works is this. Instead of R1 being the gateway at 192.168.1.2, we set up a virtual IP address or a virtual gateway address. In this case, we're going to use 192.168.1.1. And this basically virtual address is the gateway address. And both routers will assume this virtual address, and in the event that one of the routers goes down, R2 will take over this address, and if not, then R2 will stay as a backup or a standby router, and R1 will use this virtual address 192.168.1.1 as the gateway address. In reality, R1's interface address stays at 192.168.1.2, and R2's interface address stays at 192.168.1.3. So we'll take this and I'll put this in the middle just to show that this is our virtual address that we're going to use as our gateway address. So if we agree that that's what we're going to do, I'll go to my PC, PCA, and we'll change the configuration. So now the PC will think that the gateway is at 192.168.1.1. All right. So now it's time to configure our hot standby routing protocol address that the two routers will share. To do this, we'll go into router R1 and we'll go into our interface address at interface gigabit 0/0, and we'll say standby, and then we'll put in a question mark, and you can see that we need to give our standby address a group number. So we'll give it a group number. We'll just choose 1. So standby 1, and then the virtual IP address, which will start with the IP command here. So standby 1 IP, and then the address 192.168.1.1. So that's our standby 1 IP address 192.168.1.1. And then we need to set a priority number. The default priority number, standby 1 priority, the default priority number for hot standby routing protocol is 100. So what we want to do is give it the number 105. All right, let's do that again. Standby priority space 105. So now, if the default is 100, router R1 will now have a higher priority number. And we're going to tell it standby 1 to preempt. And we're also going to tell it standby, I'll put in a question mark, priority tracking, and we'll track our outer interface. And this could be useful in the case that our outer interface is going to a WAN service provider, and if the WAN service provider goes down, then the link would go down, so we'd want to track that interface. So we'll say let's track our interface gigabit 0/1, which is the interface, let's say, that's going out to our edge router, or in another situation it could be an interface going out to a WAN service provider or something like that. So standby track interface gigabit 0/1. Standby track gigabit 0/1. All right, there we go. So now if we look at the complete set of commands that we put in standby 1 and our virtual IP address. We give ourselves a higher priority number, so we'll be the active router, or we will have priority over other routers with lower priority numbers, and the default priority number is 100, so we will be the priority gateway router. We will preempt the other routers, and also we will track our outbound interface in case it goes down, and if it goes down or there's a problem on gigabit 0/1, then our priority number will drop 10 points, which will take us to 95, thereby making the other router the higher priority, and that router, the standby router, would then become the active router. If our gigabit 0/1, let's say our WAN service provider, was to come back up, then we would gain 10 more points on our priority number and go back to 105, and then we would become the active router. So now that that's the case, all we have to do is go over to R2, and we'll go into our interface, and we'll say standby 1, and also give it the IP address. And so now this router, R2, should be the standby router. There it is, HSRP, state change, gigabit Ethernet, group 1, speak, standby. And if we look at router R1, we look at the message here, HSRP, state change, state standby, active. So now we have our active router is router R1, Our active router is over here, and so this is the active router, and R2 is the standby router. So now let's test out our active and standby gateways. I'll go over to PCA. Now first, our gateway has changed. It's no longer 192.168.1.2, it's 192.168.1.1. And we'll just verify that really quickly. There it is, 1.1. And I'll open up a command prompt and let's see if we can ping it. Alright, there's 1.1 replying, so that's good news. And now I'll see if I can ping the ISP at 209.165.200.14. Alright, there we're pinging. So right now we're going through R1, which is our active gateway. So let's pretend that we have a link go down. So let's say that all of a sudden this link was to go down, or somehow the router was to fail. So we lose connection here, and now we've lost connection to router R1. We'll see what happens. We'll take a look here at router R2 and look at the messages. Look at that. HSRP state change, group 1 state standby active. So R2 has already become the active router. PCA has no idea that the connection to R1 has gone down, and you can see that he can still ping the ISP. So that's amazing. Now we'll put that connection back. Fast forward time here. Okay, so now we've put the connection back. Notice that the HSRP on R2 has gone from active now back to standby. Once again, PCA has no idea. As long as he can communicate to the ISP, it doesn't matter. There's the reply. Now this time, let's pretend that the link between R1 and, let's say this is the edge router, or this could be maybe some type of WAN provider. Let's say this goes down. So this should be the tracking. So that goes down. And the tracking information on R1, even though R1 is still up and the gigabit 0/0 interface is still up, we should have lost priority points, thereby making the standby router now the active router. Let's see if that happened. And doesn't look like it's happened. We'll see if we can still ping out. Oh, look at that. We can still ping out. So it looks like it has happened, and we're still able to ping outside. Now that's not happening through R1 since we lost the link here. So now it's being routed out of R2. And if we put that connection back, let's put our crossover cable back here. And we see that come back up. Notice the commands. Notice that interface gigabit 0/0. There's our actual IP address 1.2. Here's our standby address. Notice standby version 2, that populated in the configuration automatically. Our priority, our preempt, and now we should be pinging once again. And once again, we can still communicate, but this time it's obviously through R1. So that's hot standby routing protocol. It enables us to have a standby gateway that is available automatically in case our active gateway goes down. We have a backup gateway. Pretty cool.